frozen. Yeah, but it's frozen. It like shows me that snapshot. Fix it. Sorry, having minor technical difficulties with the ridiculous webcam. All right, I've got most people here. Okay. I think the thing is finally cooperating now. So as I wait for the last few people to get logged in, I put a reminder / announcement in the lab section, since a large number of you have me for lab, that you need to kind of keep this as like your end goal in mind. December the 15th, which is roughly 6 weeks, is the final day to turn in lab stuff. The reason for reminding everybody of this is lots of people are further behind in turning stuff in than they should be. I know that there's been a lot of scheduling problems and trying to figure out rotations and A group and B group and all that sort of thing, but we need to kind of keep that end goal in mind. I have to turn in grades on the morning of the 19th. So I need that last couple of days of that week to turn in lab grades to the other professors, for those of you who do not have me for lab. And also because I have to grade all those labs and get everything entered so that it will calculate correctly and all that sort of thing. So keep in mind, like write down on your Google calendars or something that December the 14th, which is a Monday, since my labs are on Monday, is the final day for turning in labs. So kind of keep that in mind. We are the people who B group who did lab last Monday. When I go in on this coming Monday, I will weigh all of your dried precipitates that were from the limiting reactant, and then also post that set of data. I've already posted the A group people. If you log into the lab section and you look at the announcements, all the data for the A group people is posted there because I weighed all of those. And so then this coming Monday, when it will have been a week since B group did it, I will post all of the new weights so that you can work on finishing the number crunching for your data for those. Remember that there are 4 questions on the back of your limiting reactant lab. The first one is mathematically calculate what your limiting reactant is. The second one is what's the theoretical yield based upon that data? That assumes perfect, that everything worked exactly according to plan. The third one asks you to calculate how much of the excess reactant did not get used. And then the last one asks you to calculate a percent yield for which you actually need the actual yield, which is why I need to provide you that last piece of data on your masses. So kind of keep all of that in mind. I put for A group who is coming in on Monday to do the next pair of labs, which is experiment 9 and 10. We're doing parts of each one. I have put up information on how to do calculations and some other basic information for the experiment 9. I haven't done the 10 one yet. That one's still kind of an in progress thing. I'll probably get that done in the next couple of days. And a reminder, there's no lecture next Tuesday, being election day, and in part, I think, because it is believed that the lines for voting may be possibly very, very long if you did not vote ahead of time. I think this is part of the reason why the school decided there will be no classes that day.
Will we have a class?
No, there will be no class next Tuesday, which is the 3rd of November.
I got you.
Basically, according to TCC's academic calendar, if you actually log on to the academic calendar part of the TCC website, if you scroll down through the 16 weeks of the fall semester, things to kind of keep in mind then. So no class on Tuesday, the 3rd of November. We have class on Tuesday, the 24th of November, which is the last day before Thanksgiving break occurs. There are no classes of any kind on Wednesday, Thursday, Friday, Saturday, obviously the weekend for that week. And then we come back from the Thanksgiving and we have 2 more weeks of Zoom classes. There's going to be another test in there somewhere. The 4th test will occur sometime shortly before final exams. And there is one more lab that, like the first lab of the semester was a Zoom. The last lab of the semester will also be a Zoom, where everybody can log in at the same time, both A group and B group, and everybody can log in. And I have my Tinker Toy set, and I'll have you a whole bunch of things to show you regarding how the molecules look in 3 dimensions. And I will load the instructions for that. Again, I'm a little bit behind on this, but not very far behind, just a little bit behind on that. And you'll have all of that to do, and that will definitely be turned in digitally. So like I said, I'm trying to provide you guys multiple reminders about all of this, because there's sort of like this never-ending complication about what's in person, what's digital, the fact that we're doing this weird rotation. So all of it's been kind of a little on the odd side. But December 14th, by midnight that night, I have to have everything either physically in my hands, if you turned it in to me like in class, or you had to have submitted it to me either through email or through Canvas, so that I can look at it and grade it and put grades in for labs and that sort of thing. All right, questions about the thermochem stuff before we move on to a bit of the quantum stuff. This coming Thursday, a week from tonight, we'll end up going over the homework for thermochem and answer any remaining questions. The test will go live at midnight that night, and you'll have the standard 4-day window to take the test for gas laws and thermochem combined. So are there questions about thermochem, since that was the one that's due before tonight, or due tonight?
I have a quick question.
Yes.
Off topic a little bit, but like I emailed you last night and you responded. I emailed you about because I was in your 8-day lab and I have the moles paper and you have my numbers, and like I emailed you to send.
And it's all the 8 days have been posted to the lab.
No, I mean for the one where you had to do anhydrous moles.
Which email did you send it to?
To
the TCC Edu one. I didn't.
No, it was armolar@verizon.net.
Oh, and it was about moles of.
Yeah, the anhydrous salt lab.
Okay, I'm wondering if it ended up in my spam folder. Give me a second to see if I can look and see if that's where it ended up, because I don't know why it would end up there, but it sometimes happens. No, actually, I don't see it. That's weird.
Yeah, I emailed you at like 6:42, October 27th.
Yeah. Okay. AR Moeller at Verizon.net.
Yeah.
I don't know. I mean, Moler. So I don't see it in my spam box.
Okay. I can try again
It's
tonight.
weird. If you you can. I know that I didn't check my work email last night. That's why I wondered if you would send it there, because I got diverted to some other stuff last night, so I hadn't checked that one.
Okay.
You could send it to both. You could send it
Alright.
to both, maybe, just in case. That's weird. Every now and again, Verizon does really flaky stuff, and I don't know why. Just every once in a while. I mean, okay, the spam thing, yeah, I know that happens, but every now and again, things just like go into the void. I have my editor sent me stuff back in the middle of the summer, and she ended up having to send it like 3 times. I have no idea why. It was like she and I swap email on a regular basis, and for some reason, that one particular week, it was like Verizon just dropped all the email into wherever. So yeah, try maybe send it to both just in case. So that way I'll make sure I can respond to you.
Okay.
Other tangentially related things.
Could you go over Hess's law again and with the 2 different reactions you're supposed to add together?
Okay, I'm trying to think. It's like I don't have. That's one that's hard to cook up off the top of my head. Lots of other stuff I could just kind of like pull numbers out of thin air and make them work. Let me go grab a different textbook. And yes, I probably own like 30 or 40 different college chemistry textbooks from various places. So let me see. Hess's law. All the ones I see, it would figure the ones I see that I grabbed in the tech in one of the textbooks all have 3 parts to them. Not that that doesn't work. Let me see if I can do this on the whiteboard. All right, so text. All right, keep in mind that when you're doing Hess's law stuff, that pretty much all of them have lots of given information. So the starting point has like a lot of stuff that they have to provide you with to kind of get you going. So how about if we have carbon of the graphite variety. And to that, we are going to add some oxygen gas, so O2 gas. And this will give us some carbon dioxide. I'm sorry, I can't do the subscripts for some reason. The whiteboard thing hates the subscript idea. So this is one of the 2 half reactions. So I have a second half reaction that says, okay, what if we had a different kind of carbon in the diamond format? And we also want to add oxygen gas to that. And it also makes CO2. And so I have to type the word delta because it won't let me do a little triangle. So my delta H value for the first one is negative 393.5. And this is in kilojoules. For my second reaction there, my delta H value is negative 395.4. So really kind of close. Also in kilojoules. So what I want to find is, okay, so this is my third thing. This is the one that I want to end up when everything is canceled out. I want to take my graphite and I want to convert it over to the carbon that is diamond and have none of the rest of it left over. Okay. So this is what I'm looking for. I need to flip the second of my given information equations. So up here, where it has trying to make it let me draw this one here. Okay, so try to draw arrows. So that's the one I need to flip backwards. I'm gonna go back to text here. So I need to write this one in the opposite direction. I need to have it start with the CO2 and then have it make my carbon in the diamond form. And it would have a byproduct of oxygen. My delta H for this, I'm trying to make it expand my box here. My delta H value now is going to be a positive thing. This is going to be positive 395.4. All right, the other one I'm actually going to leave written in the direction that it is written. So I'm going to do graphite one. For some reason, I can't spell graphite. My O2. And that made CO2. And this one had a value of negative 393.5. All right. Let's see if I can do my draw thing again. So okay. That one goes away. And that one goes away because we don't want any of that in the ending equation. I also can get rid of my oxygen and my oxygen. And so what's left over here means I need to add these two values together. It's going to be kind of a small number because if I do a positive 395.4 and then I have a negative 393.5, the difference between those is actually rather small. I end up with 1.9 kilojoules. So in this case, I didn't multiply by anything to make everything match up and cancel out, but I did flip one of them. Flipping means invert the sign. If it was a negative, make it positive. If it was a positive, make it negative. Hopefully, maybe that helps a bit. An additional example there.
Thank you.
All right. Other questions about thermochem stuff? All right, we're gonna dive on into a little bit of the quantum stuff tonight. This particular note set, I actually managed to find a batch of relatively relevant and importable, I don't know if that's a word, figures to put into the note set. So it gives us some better visuals to go along with what we're talking about. All right, so different screen share here. All right, we are jumping into what usually gets referred to as the quantum theory chapter. This begins with the idea of electromagnetic radiation. Now, this is not, strictly speaking, the same thing as talking about nuclear radiation. There is one overlap. Okay, there is actually one overlap, but as a generalized term, it is not the same thing. EM, electromagnetic radiation, is how you get energy to go through space. The sunlight that comes from our yellow star that we refer to as our sun, okay? All of the sunlight that comes from there, all of the infrared heat that comes from there, and a number of other radiant forms are all sort of thrown into the same basic category. Alphas and betas are a nuclear radiation thing. They are not EM radiation. They are actual particles. If you take second semester chemistry, I usually do the nuclear radiation or the nuclear chemistry chapter as the last one of the semester. So you might hear about this again, possibly. So one of the things that's true about EM is everything in the EM spectrum behaves like a wave. And depending upon whether or not you've had physics already or physics in high school or something like that, there are three major characteristics that go along with waves. They're wavelength, frequency, and speed. Now we're actually going to toss in a fourth one called amplitude, but I will call that one a minor characteristic as opposed to a major characteristic. There are lots of fun Greek letters in this chapter. And the first one starts with the lambda, wavelength. In both chemistry and physics is usually referred to with the lambda as kind of the shorthand. So if you see the lambda as part of an equation, they are referring to the wavelength. For, again, mostly chemistry and physics, usually lambda or wavelength gets measured in meters. So how do you measure a wavelength? We assume, unlike waves in the ocean, we assume more like sine waves, cosine waves, that the waves we are looking at are regular and predictable. If you measure from the top or crest of one to the next one, or from the bottom to the bottom, from the trough to the trough, that is the distance of your wavelength. And they can range from minute fractions of a meter up to thousands of a meter. So we're going to kind of see a whole bunch of variations on this theme. Now, frequency, this is another funny Greek letter here that is known as a nu. It looks kind of like a letter V that has a little bit of a left hand twist to it. So nu is representing of the frequency. Nu or frequency tells you numbers of cycles or numbers of waves that pass through a given point in space per second. So if wavelength has a unit that's a variation on meters, the units that you are going to see for frequency are either seconds to the -1. Yes, that means the seconds is on the bottom of a fraction. Or you will see it referred to as hertz. Yes, I know that sounds like the rental car. HZ. So 1 hertz, and no, it's not 1 hertz. They actually leave it like it sounds like it's plural. 1 hertz is 1 wave per second. So although you probably don't really think about it this way, if you are tuning your radio, and I know that most of us all have digital tuners in our cars these days for tuning the radio, but still, as it like flips through all the numbers looking for either a particular radio station or the next one, if you're just searching for something to look for to listen to. If it's AM, it's kilohertz. If it's FM, it's megahertz. So, okay, in my family, we listen a lot to the point 94.9, okay, FM. So that's 94.9 megahertz as the frequency. So the radio waves that are passing the car antenna, which in these days is not as impressive as some of the old-fashioned ones that were about 3 feet long and usually mounted on the front corner of your fender. These days, most antennas are about 10 centimeters long, and they're usually mounted either above the windshield or like above the back windshield, back window. They're kind of like a little short stubby tail. That's how it's figuring out what radio station you're listening to, because it's all about the frequency. Speed. How fast does a given wave travel through space? Well, if we're talking about outer space, as in outside the Earth's atmosphere, we're talking about speed of light in a vacuum. 2.9979 times 10 to the 8th meters per second. Now, granted, most chemistry and physics textbooks go ahead and round this to a much nicer looking number as they use this to do the calculations, and they call it 3 times 10 to the 8th meters per second. So to go unmetric for a second, 186,000 miles per second. Okay, which means if you travel from what more or less is the surface of the sun to the surface of the earth, it takes about 8 minutes. So when we have an eclipse, okay, and there's the moon in between us and the earth, or in between us and the sun, or if we do the other kind of eclipse where we are between the sun and the moon and it shows our shadow on the moon, we're actually not seeing it quite exactly in real time because it takes a little bit of time for those light rays to actually reach the surface of the earth where we can actually see them. So there is not sort of infinite speed. Light speed is the limit to the best we know. If you want to get deep into quantum physics, we could talk about tachyons, but that's an extra complication that may or may not follow classic physics.
Ms. Muller, I have a question.
Yes.
Is there a correlation between speed and frequency? So, like, can you have a high frequency wave that maybe moves slower than a low frequency wave, or they go hand in hand?
It's not frequency and speed, it's frequency and wavelength that have a correlation.
Okay.
The speed is actually dependent upon vacuum or whatever it's passing through. So like, okay, shine a flashlight into a bowl of water. The water has a different density, a different thickness. So there's a little bit of a speed difference when light passes through water versus when light passes through the vacuum. You could also shine light through other translucent substances that would affect their speed. And again, if we're talking about deep quantum physics here, if you shine light through an Einstein-Bose condensate, you can slow it down to about 60 miles an hour. I know I like have all this trivia stored in my head because I actually am really fond of a lot of this. So I have lots of little bizarre facts kind of at my fingertips.
Do different energies have their own value of speed in a vacuum that they typically travel at, and it's just determined by whatever medium they're going through?
It's all based on photons. I will give you kind of a wishy-washy answer. Yes and no. It's somewhat more complicated than that because it also depends upon penetration ability. There are certain things that certain wavelengths will not penetrate. So I don't have an exact answer for that.
Okay.
All right, here is the lesser important characteristic for a wave, and that is amplitude. If you have ever seen an oscilloscope, which they use for tuning everything from music to other types of like radar and that sort of things, amplitude is how high or deep your wave is. So if you're standing down on Atlantic Avenue on the boardwalk, looking out at the ocean, and we're about to have a hurricane, the amplitude is usually pretty impressive. Whereas if it's a calm day, the amplitude is usually kind of not so impressive because it's not going to have a lot of power behind it. You'll see kind of flat waves that have not a lot of height or depth to them. So wavelength, frequency, speed, and to a lesser extent, amplitude are all ways that you can describe waves. And actually, it doesn't really, truthfully, have to be confined to electromagnetic spectrum, because it can be water waves, it can be sound waves. There are other things that travel in wave form other than the EM spectrum. All right, let's start talking about the spectrum itself. So when you're usually maybe in the middle of elementary school, probably all the way through into about the middle of middle school. Usually when people talk about light, they talk about the rainbow, Roy G. Biv, red, orange, yellow, green, blue, indigo, violet. But what they often don't talk about is the fact that the visible spectrum is actually one tiny slice out of the middle of the very much larger EM spectrum. I like this example in one way, except for the fact it's backwards. Okay, I am used to seeing, or I prefer, let's put it that way. I prefer a version of the EM spectrum that shows you the cosmic ray end on the left and the long wave on the right. But we'll kind of deal with it as is. It's just backwards in the best picture that I could find to insert here into the notes. So I'm gonna kind of walk you backward through this from the right-hand side back toward the left. So look at our designations here. If you look at the right-hand end here, we've got short wavelength, high frequency. We'll talk more about that in a bit. Cosmic rays are the ones that have the shortest version. They're the ones that kind of short as we know. Okay, we've got gamma rays, X-rays, UV for ultraviolet, and then it shows you a little tiny slice there of the rainbow that shows you where the visible spectrum is. That's the one our little human eyeballs can see. And then we keep on going. IR is infrared, microwaves, TV waves, radio waves, and technically speaking, out past the end of the radio waves is another kind of, however long you want to make them, that is loosely referred to as the long waves. So this gives you kind of an idea on how the EM spectrum is broken down. So let's talk about this in a little more depth now. So like I said, I prefer to start at the cosmic end. I am definitely a fan of what they call mnemonic devices, weird words and phrases and rhymes and that sort of thing that allow you to embed information in your brain. So when I took physics in high school and we spent some time talking about the EM spectrum, my brain coughed up Sig Sauer Merle, which makes no sense, okay? However, it's now permanently embedded in my brain because I will never not remember Sig Sauer Merle is the EM spectrum. So Roy G. Biv, which sounds like somebody's name, is your visible spectrum. But if I want the whole thing, if I want the whole EM spectrum, one of my students a couple of semesters ago came up with this rhyme, and I don't remember all of it. I remember part of it. It was like, the Coast Guard X-rays under vessels in, and I can't remember what the MRL, what the words they came up for. Make yourself up a rhyme, okay? It helps you understand it. It helps you kind of stick it in your brain. In biology, one of the ones that they tend to teach is King Philip came over from Greek seas, which is the, you start with kingdom, phylum, class, etc. It gives you all of the taxonomy that goes with the species and all that sort of thing. So that's also, it's a mnemonic device thing. I'm the queen of really weird letter combinations. SSSFMO is the Krebs cycle. Yeah, again, that doesn't really make a whole lot of sense, but I that's how I remember it. So if we start at the short end, cosmic, and they're usually called cosmic rays, have a wavelength in the neighborhood of 10 to the negative 13th meters. Now, cosmic rays are generated by stars as part of the nuclear processes, among other things, that happen in the burning of the star. Cosmic rays, this gets back to the penetrating ability that I talked about. There is pretty much nothing that can stop a cosmic ray. Okay, if you are in the space station, if you are on the surface of the Earth, if you are on the other surface of the Earth, and let's see, what's opposite from us? Australia. Cosmic rays don't even know the Earth is there. They just go zip. They like go straight on through. They have immense penetrating ability, in part because their wavelength is so very short. It passes between almost everything. Then we jump down one designation to gamma rays. The gamma rays are another thing that is a nuclear byproduct. Certain types of radioactive decay generate gamma rays as one of the byproducts. Gamma rays can also be used for such things as the radiation that is used to treat cancer. They have gamma ray generators, and you can target it. In fact, they usually, people who have long-term radiation treatments, a lot of times they will tattoo a mark on your body to help them guide where they want to send the gamma rays, because they are very powerful. They are very short wavelengthed and very, very deeply penetrating. So you wouldn't want to aim them at places that don't have cancer. So this is one of the reasons why they often will do a little, sometimes it's like 3 dots, sometimes it's a little diamond. It kind of depends upon the medical community as to what exactly they use for the targeting, but that's one of their uses. X-rays. Now that begins to sound more familiar. We all sort of understand X-rays, okay? We know that, okay, if you go to the dentist, they X-ray you to find out if you have cavities. If you fell off your bike, they may X-ray you to find out if you broke something. X-rays penetrate muscle better than bone. Hence why when you look at an X-ray, muscles are a much darker color because there's more exposure, more of them passed through. The bones have a paler or whiter color on the film. Of course, these days it's digitally read for the most part. Because teeth and bones are denser, you get less penetration ability. So shorter wavelength, not as much impressive penetration. Jump down to the next one. UV is ultraviolet. Ultraviolet is generated in a number of ways. I mean, the sun makes ultraviolet. This is why you get a sunburn outside if you spend a lot of time out there, or a little time if you're really pale like me. My redheaded kid, yeah, he burns in like a heartbeat. But UV is also used for sanitizing of some medical equipment. UV, here's an interesting another piece of trivia. Tanning beds, which are sometimes known as fake and bake, It doesn't matter whether the UV came from the sun or whether the UV came from the artificially generated light source in a tanning bed, it still puts a kink in your DNA. Okay, remember DNA molecules look like the long twisted ladder. Well, if it gets hit by an ultraviolet ray, it puts a little knot in your DNA known as a thymine dimer. And if you are healthy and your skin is healthy, you have enzymes that are designed to undo that little knot in your DNA. On the other hand, if you spend a lot of time in the sun unprotected, this is one of the reasons why skin cancers are tied to long-term sun exposure. Then we get to the middle. The middle is really a small section from roughly 4 times 10 to the negative 7th meters to 7 times 10 to the negative 7th meters. This is pretty much all our little human eyeballs are designed to see. We can see a little smidge of what is referred to as the near ultraviolet. We usually see it as kind of a pale whitish purple color. And we can see a little smidge of the near infrared. Think hamburger bun lights. But that's about it. Our eyes just don't see that much of the EM spectrum. We need instrumentation and machinery to see the rest of it. Infrared, okay, gets used for lots of things these days. If you are somebody who is very difficult to draw blood from, one of the things that they have designed these days is this little wand that helps you shine on your skin. And since blood vessels are slightly warmer than muscle because there is blood flowing through them, you can use this instrumentation to kind of aim your needle directly at the blood vessel. If you are law enforcement and you want to figure out where the hostage is, okay, in the room, you can aim your device at the wall and read the heat signatures. They also use it to hunt for people buried in earthquakes because they are warmer than the surrounding ground, and they can use it for heat detection that way. So infrared has a lot of uses, and we have a lot of relatively common instrumentation that allows us to make use of those wavelengths. Microwave, 10 to the negative 2, 100th of a meter, so around about a centimeter. We all use microwaves to nuke our food. You can also use microwaves for communications. Microwave communication relays are a way to transmit information. Now we're getting toward the bottom end. Radio waves. Radio waves, obviously AM, FM. There's some short waves, which are kind of the short end of the radio waves. We not only use them for everyday purposes, radio waves can also be used to study stars. Green Bank, West Virginia is a radio telescope observatory. They have, at least last time I checked, 5 absolutely enormous radar dishes. They're radio telescopes that monitor segments of the sky to study galaxies, quasars, all sorts of things like that. And they utilize then computer programming to translate the radio information into visual images so that we can see things that otherwise we wouldn't be able to see with our little eyes. There are long waves too. Long waves are generally considered to be anything above 1,000 meters. Like the cosmic rays, they don't have a use currently So cosmic rays, we don't have a use for. Long waves, we don't really have a use for, but everything else, we have actually kind of come up with ways to make use of that information. Question.
Yeah, Ms. Mueller, I was just going to say those dishes you're talking about in West Virginia. I was actually on a ride once and went right by it, and it blew my mind. I mean, if you had it was like 4 or 5 mountain peaks, and the diameter of the dish spanned between like all of them.
Yeah, they're
insane.
several hundred feet across.
Yeah, yeah, it blew my mind when I saw it. I was like, how have I never heard about this?
It's one of those really oddball little secrets. Weirdly, okay, I visited lots of fascinating, trivial places in the US with my parents growing up. And I grew up in Maryland. So from Maryland to West Virginia is not a really enormous drive. We went to Green Bank Observatory and went on their tour when I was a teenager. So it was kind of a really cool thing to see.
Yeah.
I have a quick question.
Yes.
So there are like shrimp that see more colors than we do. Does that
Yes.
just mean they just see more different waves, right?
Yes.
Okay.
They have, okay, biology meets chemistry here. In our retinas, we have rods and cones. Rods see black and white. Cones see colors. But part of that is dependent on wavelength. So the implication would be that the shrimp have cones that are capable of detecting more wavelengths than human cones in their retinas. Other mammals have less. Actually, not that shrimp are mammals, but dogs and cats and cows and that sort of thing. The belief is that they only see some colors. Not that they see them black and white per se, but they see fewer colors than most humans do. So the implication would be that the shrimp see more because they have a different cone system, because shrimp have eyes. Granted, when you buy them at the supermarket, they're usually beheaded, decapitated, unless you shop at Grand Mart. If you shop at Grand Mart, you can buy the ones with the heads on them, which are always sort of fascinating to look at. If you look at crayfish also usually come with the heads on them. So yeah, weird kind of trivia. So the last couple of things we're going to hit on today then are, and this is what somebody asked me earlier, is wavelength and frequency are tied together. So they have an inverse relationship. And we talked a little bit about inverse relationships back when we were talking about gas laws. When one goes up, the other goes down. So short wavelengths have high frequencies. So things like gamma rays and X-rays, because they are so small, you can have a huge number of them pass your given point in space in a really short period of time. So back to the hurricane idea. If the hurricane is coming, you're standing on the boardwalk down at the beach, because there's a lot of power behind the waves that are coming in. Now the amplitude may be high, but they're probably coming in pretty fast. So you could sort of count the number that are coming in. Long wavelengths, on the other hand, go with low frequencies, because basically the long wavelength means it's a big number. So big, like 1,000, like a radio wave. If you had a 2,000 meter wave, the number of waves that are going to go past your car antenna in a second is not as many. So we combine this into an equation. More fun Greek letters. C is speed of light. I have a t-shirt, which I think I wore to lab one week, that says, you matter. Unless you multiplied by speed of light squared, then you energy. So bad chemistry jokes, bad physics jokes. C is speed of light, 3 times 10 to the 8th. If you multiply the frequency and the wavelength for a light band or for a photon, you will get the speed of light. So I picked on something that has a visible spectrum wavelength of 420 nanometers. And I want to figure out what the frequency is. So I plug it into my formula here. I've got C, 3 times 10 to the 8th, because that never changes. I converted my value of my wavelength from nanometers to meters. I want to make sure my units cancel out, because meters needs to cancel out with meters. So I did 420. I didn't write it in scientific notation. I just left it as 420. So 420 times 10 to the negative 9th. I did my rearrange and I solve for my frequency. I have 7.14 times 10 to the 14th hertz. So think about that. I had a short wavelength because it's 10 to the negative 9th meters, but my frequency is a big number. My exponent is 10 to the 14th. They're always paired that way. When one is tiny, the other one is big. And you could have it in reverse. You could have a radio wave with a long wavelength, and it would end up having a relatively short frequency or small frequency because of the wavelength being very long. So this gets us through a couple sections of the quantum chapter. No class next Tuesday, because next Tuesday is the election day and there's no class at all for TCC on that day. So sometime before you go to bed tonight, make sure you turn in your homework for the thermochem chapter that's supposed to be turned in tonight by midnight. I will grade it over the next few days, and we will go over thermochem homework next Thursday, talk about the test. I'll load the test so that it activates next Thursday night at midnight. That way you have the 4-day window to work on it. And we'll probably do a little bit more of quantum next Thursday, probably not a lot. I don't want to get deep into it before we get through the next test, but I want to do a little bit more next Thursday. So no class on Tuesday. There is class on Monday, okay? For those of you who have me for lab, there is class on Monday. Tuesday is the one that we don't have class for.
Do we have a cumulative exam at the end of this?
Yes.
Okay.
My usual mode, because I usually have time constraints under normal reality, is it's usually 50 multiple choice questions. I am undecided at this point if I am going to stick with that idea because of the way that we have done this digitally this semester. It may be partly multiple choice, part problems. I haven't quite figured that out yet. I I would like to ask a couple more, at least a few more in-depth questions since we're doing this digitally. But when we get closer, I will let you know more about that. No, like the test that we're doing in the meantime, each of the 2 chapter tests, as you have been seeing, are some multiple choice, usually a couple of true false thrown in, 1 or 2 fill in the blank. Occasionally there's a matching and there's some problems. So they're usually kind of a mix of things. I'm trying to embrace the fact that Canvas allows me to have a number of different options. So I usually try to do a bit of mix and match for all the different tests that we're doing.
And is there still at one point early in the semester, there was talk of maybe having some sort of in-person assessment as well?
I have not heard anything that will allow us to do that. To the best of my knowledge, the default, I guess, has sort of become lab is the only face-to-face time we have.
All right.
So unless somebody tells me otherwise, I will assume that the remaining 2 tests, so the test that's coming up next week, and then the test that'll be probably shortly after Thanksgiving, are both going to be digital, and also, to the best of my knowledge, the final exam will be digital also. Nobody has told me that we are allowed to have a physical test. Believe me, I'm sure we're all frustrated because we would like to actually do something kind of a little more traditional. But yeah, I think that's not happening right now. I don't know if you guys are watching. This is sort of only sort of tangentially related. I don't know if you guys are watching the numbers. We hit
It's trending up.
81. The recorded number of positive tests yesterday was 81,000.
Yeah,
And
Virginia.
there is, and that's kind of scary. And there have been implications on some of the major networks like CNN and MSNBC that we may hit 100,000 by the end of next week.
I remember, again, I know this is already a tangent, but I remember back in May, that a few of the models were showing that our largest peak would be beginning of November into December if we stayed in quarantine time.
Yeah.
So I'm worried about if we're getting this high and they already were expecting it to be high, where we're going to be at. So
in Europe, I don't know how much you guys follow international news. France and Germany have this week
just
instituted
shut down again.
a lockdown again. I'm not sure for how many weeks. I think a minimum of 2 weeks, but maybe more. Wales has also instituted a couple weeks of lockdown. I guess it happened today. All of Britain has instituted a lockdown. And some of the other European countries are motivating in that direction this week. So yeah, stay safe. This is just kind of almost like science fiction scary in a way. It's like
Your next book.
Yeah, it's like we all never thought we'd live through the plague. It's kind of like, yeah, looking at Black Death numbers. Ugh. So anyway, I will see you guys in a week, except for the people that I see on Monday for lab.
Professor?
Yes.
Can you please upload a digital copy of the book? Because I think I might have uploaded the wrong one.
I don't have a digital copy of the book. It's on the website.
The website that you gave us, I think I might have copied the wrong words. Could you give us the website to go in?
It's in the syllabus. If you
okay.
open the syllabus, there should be a hot link in there.
Okay, I'll check it out then. Thank you, ma'am.
Yeah, I don't have the link at my fingertips because I have a physical version of the textbook that I use. I don't use the digital version. I read lots of other stuff digitally, but textbooks in digital is not a good brain fit for me. So I have a physical copy of the textbook.
All right. Thank you, ma'am.
But yeah, look at the syllabus. The syllabus should have a hot link.
Thank you.
Other questions? Otherwise, I will see. Yeah, if somebody's held me up with the green one, it's like, if you order it from certain places, it's got a green cover. If you order it from other places, it has an orange cover. Depends upon where you order it from. Amazon has it. They're like $50. Otherwise, I will see you for lecture in a week.